Okay, so these double angle IDs are going to work the exact same that the sum and difference IDs worked. So this problem deals with drawing triangles using our formulas. So we are given that cosine is negative root 3 over 2 and sine is greater than 0. If you remember from before, this was just to help us find our quadrant. So if cosine is negative and sine is positive, that means we will be in quadrant 2. And then cosine is negative root 6 over 3. So use our Pythagorean theorem to find our third side. We get 9 minus 6. This third side will be root 3. So now it's just a matter of plugging into these formulas so you guys can see how they are used. So first, for sine of 2 theta, our formula is just 2 sine of theta times cosine of theta. So if we look over here, sine will be root 3 over 3. Cosine will be negative root 6 over 3. Now if we multiply straight across, and keep in mind technically that is 2 over 1, so it only multiplies into the top. And 3 times 6 is 18, so we get negative 2 root 18. 3 times 3 is 9. Always check to simplify that radical. You can pull a 3 out, so that would make this 6 root 2 all over 9, and then we can reduce that fraction. So we get negative 2 root 2 all over 3. Okay, next we're going to do cosine of 2 theta. Now technically we have 3 different formulas we can use. You can use any of them. You will get the same answer regardless. I'm just going to go ahead and use the cosine squared formula that I've written on the bottom down here. So we have cosine of theta squared, which would be negative root 6 over 3 squared, minus sine of theta squared. So sine, we already found it once, root 3 over 3, all squared. Now we just simplify that. Whenever you square a fraction, keep in mind to square the top, square the bottom. So square the negative to become positive. This becomes 6 over 9 minus 3 over 9, which gives us, 3 over 9, which is 1/3 for cosine of 2 theta. And now lastly, we have tangent of 2 theta. So if we use this formula, the top is 2 times tangent of theta. In this case, tangent is opposite over adjacent, so negative root 3 over root 6. Now it's all over 1 minus negative root 3 over root 6 squared. So now, as always, it's just the mess of simplifying all this. So on top, we get negative root 3 over root 6. We'll worry about rationalizing in a minute. On the bottom, we get 1 minus 3 over 6, which will just reduce to 1/2. So now on the bottom, simplify this out. Essentially 1 minus 1/2 just equals 1/2. So we're going to flip it up and multiply. Get negative 2 root 3 over root 6 times 2 over 1. Oops, wrote that wrong, root 6. So now we have negative 4 root 3 all over root 6. Rationalize this out, times root 6 times root 6. And we have negative 4 root 18 all over 6. We can reduce the radical and reduce the fraction. I'm going to go ahead and reduce this radical first. And 18 turns into 3 root 2, because you can pull a 9 out. 4 times 3 is 12. So negative 12 root 2 all over 6. Divide that out, and we get negative 2 radical 2. So we have our tangent, our sine, and our cosine. And now just a quick side note, another way, because tangent can get a little messy, when you're having to find sine, cosine, and tangent, keep in mind this little identity that can help us out. We know tangent is always equal to sine over cosine. So if we're looking at tangent of 2 theta, well, that would be sine of 2 theta divided by cosine of 2 theta. We've already found both of those, so a nice little way to check ourselves. If we do sine of 2 theta, which was negative root 2 over 3, divided by cosine of theta, and if we multiply by the reciprocal, that turns into times 2 over 1. Notice that cancels. We get what we got for tangent, which was negative 2 root 2. So if you see connections like that using your other identities, you can still use those to your advantage. Now these double angle identities are actually nice because we can work backwards as well. So in this case, we're given the double angle that cosine of 2 theta is equal to 1/2, and we're going to use that to find the single angle what if sine of theta. So this is where these other two forms of cosine come into play. If we know cosine of 2 theta is 1/2, if you look at these over here, where's that? Essentially that means that we know 1/2 is equal to cosine squared minus sine squared. Or, that doesn't help us much, we have two variables. Or we know 1/2 equals 2 cosine squared minus 1. Or we know 1/2 equals 1 minus 2 sine squared of theta. So we can use this, or we want to find sine squared of theta. Well, notice if we use this third formula down here, then we can solve for sine of theta. So I'm just going to write that out. Since we know cosine of 2 theta equals 1/2, that means 1/2 equals 1 minus 2 sine squared of theta. So again, I'm just substituting this piece of the formula in for cosine of 2 theta. Now if we solve this like a normal equation, we're solving for sine of theta. So we would subtract 1 from both sides. 1/2 minus 1 is negative 1/2 equals negative 2 sine squared theta. Our next step would be to divide by negative 2. Negative 1/2 divided by negative 2 gives us a positive 1/4. So that equals sine squared theta. Now again, we're solving for sine of theta, so our last step would be to take a square root. Now one tricky part in here, that means square root of 1/4, but remember whenever we do a square root, we can have a plus or a minus with sine of theta. So first, a little bit of math, the square root of 1/4 is 1/2. So we get plus or minus 1/2 equals sine of theta. Now if we look up top, we have that pi is less than theta is less than 3 pi over 2. So that tells us we are in quadrant 3, and this is how we figure out if it's a positive or a negative. We know sine is negative in quadrant 3, so that means our final answer would be a negative 1/2. And now this idea of using a double angle to get to single angle is where our last set of identities, our half angle identities, come from. So keep that in mind with this plus or minus and how you decide it as you watch that next set of notes.